Hello and welcome to the AP Stats video that's introducing data and collection unit. I'm also going to put in a little introduction to the whole year of AP Stats, just trying to give you a good overview of what we're looking at, what we're doing, where we're going. So in AP Stats, I'll start with that. And before I get going, I should really say this isn't a replacement for reading the book and taking notes and really studying the textbook first. You should be doing that first. This should be just a reinforcement of that. It doesn't include everything the textbook has. Textbook is your best resource, followed by asking questions and studying other resources. This is a reinforcement. Do you need to watch this? You bet, because you're gonna get some of my insights as a teacher, and also just reinforcing what you've already read, which is important. You can't just read it once in this class and expect to know everything. You have to see it multiple times in order to really understand what's going on. It takes time and practice for this class. So hopefully that's what you're doing. Read the textbook first, watch this video to reinforce it, participate in class and ask lots of questions, and then practice problems on your own on the side. Okay, that without that process, it's really hard to be successful in AP Stats. Okay, but what is AP Stats? Where are we going with all this? So in AP Stats, usually we're asking ourselves, what's the truth? What percentage of the U.S. population support Biden? What's the average time an ASIJ girl can swim 100 meters? What percentage of ASIJ parents would like to have masks removed from the classroom? Right? These are important questions. Especially the last one is one that we're battling with right now, right? Do we continue wearing our masks this year, or are we going to take them off? So, what's the truth, and how do you get to that truth? Well, let me work backwards a little bit here. Well, sorry, here's the process. First, you collect data, which to me is the most difficult part, to get good data to find out what that truth is. It's really difficult, and people do it incorrectly all the time, leading to bias, right? Leading to different biases. And they'll get an answer, and they'll spout that answer off at the top of their lungs sometimes. But actually, a lot of times that truth that they think is a truth is not. They did the collection wrong, so therefore the truth that they think is a truth is actually wrong. And they'll make decisions, and they'll yell at people, and they'll tell people they're lying, and they'll try to get you to persuade you to give them money and everything, based on some bad data and a bad truth, an untrue truth, right? So we want to make sure that's the most difficult thing, getting good data. So that's what we're going to talk about today mostly. Now, after you get good data, there's mechanics behind it, like doing the calculations to figure out, and we'll get into it later when we do inference. You don't have to worry about it yet. But there's mechanics involved, but your calculator really does a lot of this for you. So that's the easy part. Just let the calculator do it. Now, you do have to interpret your results. And that's a little harder. You do have to kind of understand what's going on in the background of everything. But I call that kind of medium difficulty. The really difficult part is getting good data. And there's pieces to this. And you'll find out as we get into inference towards the middle of the year that we're going to have conditions, right? We're going to be like, there's certain conditions you have to meet in order to know that you collected good data. So what we're going to focus on today, though, is the randomness a little bit, and also some probability, like why do we need to know about independence and sample size and all this, right? So, and we're going to talk about what's unusual. How do we know if something's unusual? This is another goal of ours a lot. Sometimes we're just looking for some number, like what percentage of people or what's the mean of something. But sometimes we just want to know, is something unusual? For example, someone claims they have ESP. Well, how are we going to prove that they have ESP, right? Or not, right? How are we going to disprove it? We can't just take their word for it, right? And we can't just say, well, it seems like it, right? We want to have statistical proof. Another example might be like, let's say a university only has 3% of their population as identifying as Asian, let's say, right? So you might say, well, that's a really low percentage. It should be higher than that. I think the school's being racist in their admissions. So how do we prove that though? Because maybe it's just the students who were interested in that school happen to be of a certain race. And maybe it's just because of randomness when they randomly selected the students to be accepted into the school. Maybe it just happened to be from randomness that 3% of the people were Asian. So, how do we know for sure? How do we start telling a university, hey, you are wrong? And how do we could take them to court and we can sue them and we can make them change their practices. So, how do we make these decisions to make a change in the world if we don't have proof, right? So, we got to have proof. So, how do we prove something is unusual? So, that's what we're going to talk about today and look at that. The truth part here, we're going to get into more later. The percentages and means and stuff will come later. But the idea we want to look at today. All right, so let's get right into it. I mean, that's kind of big picture of the year, right? So let's get into today's. We're going to talk about randomness and probability. So why do we have these conditions and how do they affect probability? And then we're going to look at this, like how do we think about something being unusual or not? All right, so randomness and probability. Um, Randomness does a lot of things for us. And when we take a sample or we try to collect data, we really, a lot of times, want to include randomness. Why? Well, let's go back to the example of masks at school. And let's say I want to ask the ASIJ parents, do you want to have, should we still continue to have masks at school or not? Well, there's all kinds of parents. There's different religions, different sexes, different ages, different people work or they don't work. People have different incomes. There's all kinds of different people. And so your first natural reaction might be to say, well, we need one of everything, right? I want to make sure I get a male and a female and a Muslim and a Christian and an Asian and a black and a white I want to make sure I get all these different kinds of people in my survey. Well, it's impossible to guarantee that, right? Unless you did a census. Now, maybe for ASIJ parents, it's possible we could do a census where we went and we asked every single parent, we got every single parent's opinion. But that's a lot of work, right? It's difficult, and sometimes you send out a survey and people don't respond, and then there's problems involved with it. So maybe you get some bias going on because maybe the people who were working don't respond to your survey because they're busy. And only the only people who responded to your survey were the people who were not working. And they might have different opinions about masks. Maybe the people who work all day long, they were like, they have to go to an office or something. They have to wear their mask all day and they know how not fun that is, right? So they're like, oh yeah, I don't want masks because I understand how difficult that is, right? Where someone who is working at home, or maybe they don't work at all, maybe they're like, masks are no big deal, so why get rid of masks? Be safe, So they have different opinions, and so if you only get one of those groups, you're going to introduce bias into your survey. So that's bad data collection. So how do we get around that? Well, you can do a census, but that's difficult, it's expensive, and a lot of times it doesn't work because you don't get everybody in your survey. So, what's better, what's easier, what's less expensive, or sometimes you just have to do it anyway. Like, let's say I was trying to do the Biden thing and trying to find out what percentage of the US support Biden. There's no way I'm going to do a census of the whole United States. That's impossible, right? I mean, forget about it. That's not going to happen. So you have to do what we call a random survey. You'd have to randomly select certain people. And there's ways of doing it, which we're going to talk about in this unit, to make sure that you get a, a representative a representative group of your population, right? So that's what we're doing. We're going to randomly select people. If you truly randomize your selection of the ASIJ parents, you're going to feel pretty confident that you get a little bit of everything. You're going to get some males and females. You're going to get some different races in there. You're going to get some different religions. You're going to get some different opinions about the mask or no mask. So you feel like you're going to get the truth, which is most of the time it works, right? Now, there is a chance that when you do your survey, for some reason, the people you picked just happen to be all male, or they happen to all be Christians or something, right? And sometimes that happens, and but you can't get around it. It's really hard to get around that. So there's ways that we deal with that in stats, and we'll talk more about that as we go through the year. But most of the time, it works. The randomness will give you a good view of your population, and it will reduce your bias as much as you possibly could. So we love randomness. We're going to talk about, did you randomly select the whole year? Okay. The other part is probability. If you get a good probability, then, whoops, going the wrong way, it's going to represent the truth. And that's the whole goal, right? What's the truth? Or what's unusual? Is what I'm seeing really, like, is that probability of happening, is that something I expect to see, or something that is so unusual that I think it's not true, like they're lying or something's wrong. And you'll see what I'm talking about as we go. But we want these probabilities to represent the truth, right? So we have to worry about things. We want the probability to be as close to the theoretical probability as possible. Like, theoretical basically means the truth, right? If I flip a coin, I might flip it 2 or 3 times and I could get all heads or I could get all tails. And you might think, well, the probability of getting a heads isn't 50-50 anymore, right? It's different because I got 3 heads in a row. And you're like, oh, wait a minute, that's not 50-50. But if I flipped a coin many, many times, eventually, right? Eventually that probability is going to level out at 50%. The first flip you might get a heads, and then you might get another heads, and then you get a tails, and then you get another tails, and then a heads and a tails and a tails, blah, 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 blah. But over time, it's going to level off to that 50% mark. If I roll a dice, the probability of getting a 6 is going to be 1/6, but over time. When I roll a dice just once, it could be anything. I could get a 2, I could get a 5, I could get anything on that dice, right? But over time, the probability of getting a 6 is 1/6. So we're going to talk about sample size this year a lot. We have to make sure that we get a big enough sample size that our probabilities kind of level off and we get close to the truth. We get close to those theoretical probabilities. So we want to have a good sample size. So we'll talk about that. So that's law of large numbers, kind of talking about that. We also want to make sure our groups are independent. That's a condition we're going to talk about. Why? Again, we want to make sure our probability tells us the truth. So going back to the parent idea, let's say instead of doing a random sample, I just go around and I ask, like, let's say I'm friends with a bunch of parents, right? So let's say I just go and I ask the people that I'm friends with from the parent group, and I say, hey, what do you guys think about the mask thing? And they, all I'm doing is getting those people who kind of think the same because they're in the same clique, right? They're in the same group of people, and they're not independent of each other. They kind of, their ideas are dependent on what the other person thinks. If I think one thing, then maybe my friend kind of thinks the same way I do, and somebody else might think differently, right? So if I just survey the people who are my friends, it's going to be a dependent situation, and this probability is going to be off. It's not going to represent the truth anymore. So we're going to talk about, we want things to be independent. We want to make sure that one probability is, or one answer isn't affecting another answer. So our probabilities are true, right? So don't worry too much about these right now. I don't want you to stress about all the things I'm saying. Just have that idea in your mind right now that, randomness is really a good thing because it reduces bias. And we're going to be talking about making sure probabilities tell the truth, right? We want to get those probabilities to tell us the truth, or get a probability that really shows us if something's unusual or not. So how do we get good probabilities? Well, let's look at randomness and let's look at how we can get probabilities. So these are 2 different sets of data. One was made by a human and one was made by a computer. They're supposed to be random flips of a coin, heads or tails, right? So you're going to notice that this set has a group of like 8 heads in a row. Now, a human normally wouldn't say that was random. They would just be like, oh, tails, tails, heads, 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 tails, 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 heads, right? And you get a set that kind of looks like this. So set number 2 was done by a human. Set number 1 was actually done by a computer. And you'll notice you'll get strings of things that you wouldn't think was truly random. But randomness is weird. Like a lot of people don't understand what real randomness really looks like, right? They think it can't, there's no way you should be able to get 8 heads in a row. Well, if something's truly random, it happens a lot. It happens all the time. That's why we talk about the law of large numbers. We have to have a large sample size in order to get to those theoretical probabilities. I was in Atlantic City once playing roulette, and I was betting on black and red. So I started playing red, and it hit black like 13 times in a row, and I lost a lot of money because I was like, well, it's got to hit red eventually, right? Which eventually it does over the really long term. It hit red, but it went black 13 times in a row, and I lost a lot of money on roulette. Okay, so yeah, when we talk about sample size, we're going to keep that in mind. But for now, we're just saying what you just need to get an idea of what's random. This set might seem random to you, but it's really not. You need these large strings as well as the short strings to kind of see what true randomness really looks like. How do we get random? Like, how are we going to do it in our class? So there's two ways. Let me kind of jump around here. We're going to do a simulation here, but let's get back. Let me show you two ways that we can get randomness. The calculator will give you random integers. You can see I'm using something called a random int, right? Random integer. And you can say, let's randomly select numbers from, in this case, I put 0 to 9, which we're going to do a lot. Or maybe you can see here, it's 0 to 99. And I said, then you can pick as many numbers as you want. Here I said 5, but let's say I want to pick 20 numbers. So it'll give me a string of 20 randomly selected integers from 0 to 9. And we're going to use this as kind of a random digit table. And we're going to say, okay, if I were to number all the ASIJ parents, I would say, oh, I'm going to go survey parent number 9, survey parent number 2. I don't have to do 2 again because I already chose them. So I'm going to choose parent number 1, parent number 0, parent 7, parent 4, parent 3, right? And this is going to help me determine which parents or which things that I am randomly selecting, right? So we can do it on our calculator. We also have things called random digit tables, right? Which is, I think I have one on here, I thought. Whoops, I don't have my random digit table here. But it'll kind of look like this, but it'll be just numbers, right? Can I pause? I'm going to pause this 1 second. Oh, it won't let me pause. Sorry. But like there's lists of numbers that are just random, like, and we'll look at it in class. I'll give you one of these, but it's just a sheet of paper or a book that has just strings of numbers listed out, right? And then you would use that just like we'd have a list of numbers here. It would kind of look like if I did this and said, let's do 300 numbers, right? And it would just be this big long string of numbers that would go on and on and on and on and on, right? And you would use that as your random digit table. Okay, so we can do it on the calculator, which we'll do a lot of, or sometimes on an AP problem, they're going to give you like this string of numbers on paper, and then you just have to use that group of numbers, that string of numbers, right? And just have to use that properly, right? But it's the same thing. It's just a set of random numbers that you need to kind of identify with and kind of what do we call it? Assign to parents or things, right? Okay, so what are we doing next? The last thing, setting up a simulation. How to do a simulation on something. So in a simulation, we're trying to find out if something's unusual or not, right? So I'm going to use this, like the notes are here. You can pause this and read through these and stuff. But I'm going to do a basketball player shoots, or they're claiming to shoot 80% free throws, right? So they say that's my success rate. I can shoot, when I do free throws, I'm 80% correct most of the time. Hi. Sorry, I'm making a video right now. So sorry. So 80% of the time. So I want to explore that. I want to know if they're telling the truth or not. I want to know if like, let's say I observe them shooting, right? They're shooting free throws, and then they only make like 3 out of 10. And I say, "Oh, wait a minute. You said you're an 80% free throw thrower, but you only made 3 out of 10. So I'm starting to believe that you are not an 80% free throw thrower, right? That you're less than that, you're worse than that." So how do I check that out, right? What do I do? Well, what you can do is run a simulation. And in order to find out if something's unusual or not, is it unusual for someone who really is an 80% free throw shooter to sometimes just get 3 out of 10? Is that really, really, really unusual? Or does it just happen every once in a while and I just happen to see that happening? So how do we know? Can I start telling them I don't think you're an 80% free throw shooter or not? So we want to know if the what I saw is unusual or not. That's where we're going. So let's kind of do this simulation real quick and then we'll be done for this video. So I got to set it up, or I got to assign this, right? I'm going to say, okay, they said 80%. So let's say, like, if I go from 0 to 9, you can think about the 0 kind of representing 10, right? And then the rest goes from 1 to 9. So 1 to 9 plus a 0 makes 1 to 10, basically. So that's going to represent my percentages. And I'm going to shoot 10 shots, right? I'm going to shoot 10 shots. And they claim to say that they're an 80% free throw shooter. So I'm going to say that anything from 1 to 8 is a success where they actually made the basket, and a 9 and a 0 are going to be a failure where they missed the shot. Okay? And I'm going to simulate that because, why would I simulate it? Well, I could make the person stand there and shoot, thousands of shots, but it's going to be easier to kind of see what the truth is and see what those theoretical probabilities are if I just run a simulation, right? If he truly is an 80% free throw shooter. So I'm not going to do a survey. I'm not going to do an experiment. I'm not going to make them shoot over and over and over and over and over again because, things could change. I am going to just run a simulation. It's going to be easier. So let's do that. So I do this, I get all these numbers. Now you'll notice that I got some repeats here, but that's okay, right? Sometimes repeats are okay and sometimes they're not. Here, each one of these represents a different free throw. So they're all kind of independent things and they're um, like I don't need to remove one. But if I'm randomly selecting people, then if I get a repeat, I don't want to survey the same person twice. So I have to skip repeats, right? So you just got to be aware, like sometimes do you want repeats or you don't want repeats? In this case, repeats are fine. So a 4 means I made it. So we're going to start labeling these. And if this was on paper, I would actually label this success, 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 success. I got all successes here. I don't see a single one that is a failure. I don't have any 9s or 0s. So those are all successes, right? And I'm going to record that down. Oh, I got 10 out of 10. Whoops, 10 out of 10. And then I'm going to do it again, right? And then I'm going to record that. How many successes? Sorry, let me erase this. So we got, whoops. So we got 10 on our first trial. On my second trial, I got all 10 again. So I got 10 again. Then I've got, this one has 3 misses. So I got 7. And then again, this one has only 1 miss. So I got 9. Whoops. And then we have 10 again. And whoops. And 10 again. And on the next one, I got 2, so that's 8. I'm going to try and do this 10 trials, right? I'm trying to do 10 trials. Whoops, I didn't want to do that. What did I say? 8. So then this is 9 and 7. And let me do one more. This is 1, 2, 3, so 7 again. So I ran a simulation throwing 10 free throws with an 80% chance of success. So if that person is telling the truth and they really are an 80% free throw shooter, in my little simulation, which in reality I'd probably do it more than 10 times, I'd probably do it 100 or 1,000 times. But in my little simulation of 10 times, I never once saw them shoot three or get 3 out of 10 makes, right? It's a 7 or above, like almost every single time. Even if I did 100 trials, it's, possibly I might start seeing some sixes and fives every once in a while, but I would not really expect to see that three, like the person only makes 3 free throws if they truly are an 80% free throw shooter. So this is what I'm talking about by unusual. It's really, really unusual. Like the probability is really, really low that if they really are an 80% free throw shooter, the probability is really low that I would see them shoot 30% correct out of 10, right? Shoot 3 out of 10. So I have evidence now to go to them and say, hey, this doesn't happen. If you truly are an 80% free throw shooter, you shouldn't be shooting 3 out of 10. So I don't believe you anymore. I don't know what your true percentage is, and I'm not gonna know until I like actually did some experiments and stuff and did some more data. But I know that 80% is probably not true. It could be true. Remember, anything's possible, but it's probably not true. So you're probably worse than that. You're probably lower than that. I don't know where, but probably lower than that, right? So I'd have to do more data to figure out, what the truth is. I can't say he's a 30% free throw shooter either, because I don't know that either. I just know he's not an 80% free throw shooter. So I'm going to start doubting his truth, right? Okay, so that's what we're looking at as unusual. We run a simulation trying to find out what the probability of something happening is. So we kind of assume what they told us to be true. We go with that, and then we see like what's usual. What if you really are an 80% free throw shooter, what kinds of distributions do we see? Well, we see a lot of sevens, eights, nines, and tens. We don't see threes, fours, and fives very much at all, hardly, right? If ever. So the probability of getting a 3 out of 10 is really, really low. If that's really, really low, then I can start to doubt your claim. If the probability was really high, like if I in my set here and all these trials that I did, if I got a bunch of threes in it, then I'm going to say, oh, well, that's just usual. That happens, and I'm not going to doubt you. I have no evidence to say that you're not telling the truth. Like, I'm going to believe you, right? Okay, so that's kind of where we're going with this. And let me go back to big picture. Sorry, I got to erase all this. Almost done here. Stick with me. So this is the components, if you will, of running a simulation. What's the component? It's like, what are you doing? Well, we're shooting basketballs, so I want to shooting free throws. So I want to represent shooting a free throw. So what's an outcome? Well, I'm going to assign those digits to shooting a basketball, and I'm going to assign some of them good, some of them bad, and whatever. I'm going to run trials, and I'm going to use those trials to find out what the probability of something is. So then I can come up with a response and say, this is what's usual, this is what's unusual. And then I can kind of interpret that and say, this person is probably telling the truth, or this person is probably not telling the truth, right? And that's kind of where we're going with this. Sometimes it's a probability thing, like we just got done doing, but sometimes you're just looking for the average of something. Oh, or looking for a percentage. What's the percentage of this? What's the average of that, right? And you'll see, and you have to work more examples in order to see the various types of running a simulation. But you need to know how to run a simulation and how to interpret that simulation. And you need to know these parts of the simulation. Okay, do some more practice and get some more work in. And we'll see you in class. Ask lots of questions.